appreciate what the scientist like Dr. Wayne and his research team does because really they invent and design the technology that goes behind the kind of work that we do when we do installations. So I thought what I'd share today, I come from the engineering background. So, you know, what does it take to be an ITAC engineer? We are not research engineers, we're application engineers. So I want to share a little bit about my improbable path. One, how I ended up in Virginia. I'm an Alabama native. And also what I do today. And when we look at engineering, engineering by applying is what we do in our business. And then last is our effort to grow generous leaders in our company. And so I want to share with you guys what it takes to be an engineer in our company, what we're looking for as you prepare students that are going to go into the science, math, and technology fields. You know, I have two children, two grown children, and I was not successful convincing either one of them to go into the engineering field. They both became scientists. So my daughter, both of my kids are married. My daughter is continuing her education after working for 5 years in the science field. She's at Southeastern Seminary working on her master's in divinity. Her and her husband both are planning on going to the international mission field. And they're going to leave next May and take my 1-year-old granddaughter with them. So I'm adjusting to that. And then my son, 2 years ago, he completed his doctorate at William & Mary. He has his study and field of studies in physical oceanography. And he studies hurricane modeling and flood and predictive modeling for hurricane flooding. And so he does a lot of work in the tidewater area. So I will go ahead and move forward with opportunities to share. I did want to share a couple things that we do as a company. We work with the Virginia Manufacturing Association, and we do a camp every year called Dream and Do It. It's a manufacturing camp for rising juniors in the Prince George, Hopewell region, and we partner with the chamber. So what we do when we put on that 4-day manufacturing camp at our shop and facility is that they come in, they run CNC machines, they come up with their design, they manufacture and market a product, and they compete against each other. On Saturday morning, they have to present their marketing presentation, their product, their sales price, their budget, their schedule, and they compete, and all the parents are there to see that take place. So that's a fun thing that we do. One of the other things that we do, I work for a guy that's our CEO that founded the company, and one of the things that he taught me was generosity. And so one of the things we partner with the YMCA. I realize a number of you are middle school, high school teachers, and one of the things we do with the YMCA is that they bring in middle school students, and we do a lunch and learn at our office, treat them to lunch, and share with them what we do in the construction, manufacturing, and the engineering fields. So there's a couple things we work on from a community standpoint with, all right, I think she shared with me how to make this move. Went the wrong way. There we go. All right, share with you, we started in 1988. Cindy Harrison is our founder. So we have anyone from Thomasdale High School here? Okay, no Thomasdale High Schools, just up the road. He was graduated from Thomasdale High School. He got his bachelor's in mechanical engineering at UVA. He hired his first employee in 1989. I joined the company just a few months later in October. I was the 10th employee. Today we have 450 employees, construction, craft personnel, electricians, pipe fitters, and we have about 200 engineering and technical design people. So we've grown considerably. I've been serving as the president of the company for about 15 years now. I'm married, one wife. married children, and my granddaughter that I shared with you. She is the light of my life, and grandchildren are awesome. If we could just figure out how to skip that in-between part, and just go right to the grandchildren. But, I love my children. I'm very proud of what they have accomplished. One of the things we do as a company, and sharing with you guys, what does it look like to prepare a student for engineering field through college, and then what does it look like to become an engineer, is we hire 4 to 6 engineers every year, new grad engineers. We recruit at most of the universities. From Virginia State University has an engineering program, to Old Dominion, UVA, Virginia Tech, and of course VCU. We have 4 to 6 interns that we hire every summer. Before you ask me, or anyone that has interest, is we've already filled our intern positions for this summer. We do that. We usually have those locked up in March. So as you might imagine, those are finding an internship in the engineering field very important from a scholastic and a career standpoint. So I want to share a little bit about my background and share with you some values. We're a values-driven company, and I've been told numerous times, mostly by our HR director, is you cannot use the word love in business. Well, we do. Is that we feel it's very important that we show love and respect for all the folks, that our clients, our co-workers, superiors, and our workers, and to create a very direct and honest communication. So when we look at new folks coming in, we want them to embrace our values. The other one is the ability to teach and lead others. I tell our organization is when we think about the opportunities for our organization to grow, not just in numbers or size, but to grow, it's about maximizing the opportunities for those that work for us. Our ability to be able to lead and teach them is our greatest asset to being able to accomplish what we set out to do. Our innovativeness to day-to-day work, I'm going to share with you guys the engineering tools that we use on a day-to-day basis. But we are a project-oriented, project-driven company from a project accomplishment. Somebody mentioned economics. Almost everything we do is tied to economics. We work for industrial and manufacturing companies. They're making a product. They're in business for a reason, not just to produce a great product for their customers, but to also be profitable. And so when we think about values, what often I hear from our employees is, why do we believe what we believe? Where did this come from? So I'll share with you where I came from. So it was a pretty improbable path. I grew up in rural Alabama, and this is a 2-room schoolhouse. And this is where I went to school for the first 6 years. Finished 6th grade there. Each teacher, you guys might gasp when you hear this, each teacher had 3 grades that they taught in the same classroom. And so that's kind of the old style. Now, we had responsibilities we had to do. So if you were one of the young boys, your job was to go out, and yes, they gave us a hatchet, and we went out and we chopped kindling, and we brought in coal, because our rooms were heated with pot-belly stoves. And so we got indoor plumbing when I was in the 3rd grade, so we had outhouses until that point. I share this with you because even though this was our surrounding and what I grew up with, we had economic challenges, everything from those that were the poorest of the poor to those that were quite wealthy that went to the same facility. But the quality of education was quite good. So when on the surface it looks like we didn't have a lot, how did we make education strong and successful? But what we found is that through the teacher engagement and through the parental engagement and family engagement, it created for a very rich atmosphere. My dad did not finish college. He was drafted into the Korean War, and so he left in the middle of his college career to go and serve. And my mom, she went on and she became a third grade school teacher. She finished her college degree after she raised 3 rambunctious boys that spent most of our time outside misbehaving. And so from an educator standpoint, I watched my mom demonstrate what teaching looked like. And I was the victim of her first class that she taught in the 3rd grade, and I can tell you it was not a pleasant experience. You know, it created some improbable learning. One of the things I wanted to share with you guys, so to understand the environment which I grew up in, is my mom shared with me, I was in Alabama this past week visiting my parents. She'll be 80 this year. And she says, "John, I want to show you something." And she pulled out this booklet, and it's called Take Time, and it was given to all the school teachers. And it says it's an inspirational handbook for teachers. It's compiled by the Spiritual and Moral Values Committee in 1964 and 65, and published by the Alabama Education Association. It's pretty fascinating how things have changed in the educational system, and when I looked at that, and I read through some of the passages and poems that were written, and it's about the caring for students. So I look at it in the job that I am now, and I serve as president, and growing engineers is how much I care for our employees, how hard I work for our employees to make sure that they're reaching their maximum potential. So what does it take to become an engineer? Now, once you go and you do a 4-year degree at an accredited university, it's important that it's accredited university, because if it's not, then you have to have much more practical experience to reach a point in which you can become a professional engineer. So it's 5 years of practical experience after you've gone through an accredited facility, 3 referrals in your field by other professional engineers that are already serving, have to pass an engineers in training exam, and then you have to pass and complete the professional engineers exam. We have all disciplines of engineers in our facility, from mechanical, electrical, chemical, civil, structural, and we also have project management professionals, which is an additional certification. Not all of our project managers are engineers, but most of them are. And then, once you're successful at that, you receive the seal when you register with the state of Virginia, whichever state you're registered in. We are licensed to do business in 26 states. And I can tell you it's interesting because the laws are different in every state. So it's a challenge. But the engineer would receive this seal. The company doesn't own the seal. The individual owns the seal. They become a professional engineer, and they are licensed with the state. I'm going to share with you the engineer's creed, which is important because we go through discussions on a regular basis in our office about making sure that the engineers are maintaining their pledge and promise to the community. And so this is what a professional engineer, and this comes from the National Society of Professional Engineers. It says, "I pledge to give the utmost of performance, to participate in none but honest enterprise, to live and work according to the laws of man and the highest standards of professional conduct, to place service before profit, the honor and the standing of the profession before personal advantage, and the public welfare above all other considerations. They take this creed in humility and with need for divine guidance. I make this pledge." So this is a pledge that all engineers and licensed take when they become a licensed engineer. So take us through some tools that we use. Everything from the basics of AutoCAD, which I'm sure many of your schools have, or you use Bentley, MicroStation, SolidWorks, Intergraph. AutoPlant is a 3D modeling system. Intergraph CADWorks is probably the one that we use most in our office for 3D modeling. There's Caesar pipe stress flow analysis. I was in a conversation earlier with when you think about all of that we do software-wise now. I was sharing with someone earlier is that we used to, when I started in the profession, you would have one engineer to about 6 to 7 designers. So we would engineer their sizing and doing the calculation and making sure that the flow rates are going to be right and the size, pressure, temperatures, and that the service is going to be correct. The designers are making all the physical attributes of the project work, making sure the measurements are right, it's installed correctly. And today, it's about 1-to-1. One engineer to one designer. It's how much our industry has changed in the last 20 years. So others are flow technology, ChemCAD, that does chemistry, chemical reaction modeling. The other thing is that sometimes the software doesn't give you the right answer. And it's an engineer's job to make sure that he understands how the software works and that the theory behind the software is understood so that he doesn't just plug in the numerical factors and believe the answer that it gives him. So the other part I wanted to share with you is what is very prevalent in our industry today in going out and making modifications to existing plants. This is a 3D laser scanning. We take it into a point cloud, we model the development, and we produce engineering drawings. This scanner here that we use, it scans 1 million points of data per second, and its accuracy is 3 millimeters at 50 meters. Or if you look at it, think of it as from end zone, back of end zone to back of end zone on a football field, it's millimeters of accuracy. So if you think about that, well, what does that mean in the world that we live and design? So I want to show you what that looks like. All right, this is a 2-dimensional, ugly, isometric drawing. This is very important work product of an engineer that they're going to produce through their designer counterparts. I know you can't read that, you don't need to. What I'll tell you is there's a lot of dimensions on there, there's a lot of angles, counterposing angles, there's bends, turns, and whatnot, and it's all very, very meaningful if it's going to fit after it's fabricated into the facility that it's intended for. Now the engineer's job is not to make sure all the dimensional aspects of the is correct, but to make sure it's actually going to function correctly when it's installed. So how do we start by doing that? So we do a 3D laser scan. This is what we call a point cloud. So there's millions and millions of points. It looks like a photograph. Each point has an XYZ coordinate. So when our designer goes in, he can pick a point anywhere. Let's say he wants to know where that corner or that point right there is on that job. He can pick that point. It'll give him an XYZ coordinate. He wants to know what the dimension is at this point. He picks that point, and it'll tell him exactly what the dimension is. It will actually give him the arc of the curve of what that existing piece of ductwork is. So 5 years ago, you could not do this with any level of accuracy or efficiency. It's how much the software and the tools have advanced in this short period of time. Okay, so what do? We go out, we do this, set up our tripod. I'll show you a couple other things. Right there, you can see there's targets. There's two right here, there's another target here on the floor. And we'll take our laser scanning camera, and we'll move it around to 5 or 6 different locations. We'll scan it, and we'll load it into the software called Cyclone, and it will stitch all of those photographs together and create a 3D model. This saves a tremendous amount of engineering and design time in the field, making measurements. Then we'll take the software and we'll start modeling. We'll tell it that's a round duck, and it'll start filling in all of the shapes that we're going to use. Then we go to the top side of the facility. This particular facility is at a coal power generation facility. This is a scrubber, particulate scrubber. So all the pipe and the ductwork that you see, it's coming off of the power generation facility. It's taking the exhaust through the fan and through the piping up through what we call a scrubber, a particulate scrubber. It's going to scrub out the nasties that we don't want to go into the air. And then it'll be emitted into the air. So some of the things we have to do is overcome limitations of the tools that we have. What's missing right there? Half the pipe, right? Anybody got an idea why we can't see that part of the pipe? It's not really a trick question. It's just it's practical. Is that we couldn't get our camera. We're 60 feet in the air. We'd have to set the camera out here in the middle of space to get that side of the. So how do we fix that? Obviously, we can't. We have to get that corrected. And so the modeling software in our designer will lay in the pipe and into space to create the final model. So when we're all said and done, from the different layers that we looked at, this is a scan of the whole plant. You can't tell in a great resolution here, but we can go in and look at any point of this that we want to, down to an eighth of an inch. So every point that you see has a physical XYZ coordinate. The red that you see is where we have placed the model of what we're going to have to final design and fabricate and build and install. So we're back to the drawing here. And so this is an engineering deliverable. And what this drawing goes to a fabricator. And I want to impress on you how important mathematics is at every level. Obviously, we know an engineer, they have to go through many levels of mathematics and calculus and algebra and differential equations, and then we have our designers. But even our pipe fitters, we run a pipe apprenticeship school at our business. We did not have a pipe apprenticeship school in the state of Virginia. Does that shock you? It did me. So 3 years ago, we started and got it certified through the board in the Department of Labor, and so we have a pipe apprenticeship school now. The challenges that we have is that a pipe fitter welder needs to be able not only to read this drawing, but he needs to be able to do the proper calculations in geometry, in trigonometry, and algebra so that he can actually fabricate this. We have had to just put in an additional class in our pipe apprenticeship school for remedial mathematics to teach them how to do this. I know some folks come out of school, they think, well, I'm not going to be an engineer, I'm not going to do this, I don't need to know this mathematics, I don't need to know geometry, I don't need to know trigonometry. I can tell you the best trig person I ever met was a carpenter. He was fabulous. And so when you think of that and impress upon your students that all of these fields that we look at in the technical field is important. So I thought I'd share with you, this is a recent project we just finished. So the tools that you saw, This was a design build job where we designed, fabricated, and installed. This is at Stone Brewery, the new brewery that's being built right there in downtown Richmond. And this is their utility system that we did a design and installation on. And then our electrical construction, you'll see over in this area, this is where all the controls, PLC, microprocessor controls that will control the chiller, boiler, air compressors, and chemical treatment systems and so forth. I thought I'd share with you a list. Folks always know, well, who do you work for? What type of work do you do? And when you look at Altria, Philip Morris, Dominion Power, so we work in the large chemical manufacturing, pulp and paper world. I was telling someone else, is the dirty or the better? So we work in the dirty, the nasties plants. Now this doesn't look so dirty and nasty, does it? So this was built in our Power Systems Solutions group. This was built in our shop. This is an electrical power control center that we built for NASA. And this controls their substation power distribution. And so we designed and installed this product for them. And so that was one of the projects that we did. Now when you think about engineering, if there is a shortage in any engineer right now today, I would tell you it's in power engineering. There is a desperate deficiency in enough power engineers. Everyone wants to go to computer engineering. They want to go into controls engineering, software engineering, but power engineering is an area that we do not have enough engineers. So please share that with your students.
What do they do? Someone who's a power engineer?
What does a power engineer do? They design the power and distribution of how medium and high voltage power is going to be distributed. Everything from a substation level, which might be 15 kilovolt, down to 480 volts in a plant setting. In your home, what voltage do you have? 110, right? You have 220 for your dryer, or maybe your stove or oven. Everything else 110. All industrial plants are on 4160 volts, 4160 volts, down to 480 volts. So what we need is power engineers that not only know how to distribute that power safely through relays and controls and so forth, but also at the substation level as we bring it in to the industrial plants at 13 kV and above. So high voltage and medium voltage power distribution is an area that we struggle to find all of our needs. We also do metal buildings and solutions, power protection solutions. This might be of interest to you guys. This fall protection is about 60 feet off the floor. We designed the systems and harnesses and installed these. This is at the John Paul Jones Center in UVA that we did all the fall protection for them. This is at the ethanol facility in Hopewell. We designed and built this structure here. We did 5 structures on that plant site. This is down in the Tidewater area, which is a waste refuge center. So the other thing I should talk about leadership, and what do we look for at ITAC in leadership? And when we think about our students that are coming out of school, one of the first things I tell our new employees that come in is that you can be a leader wherever you are. You don't have to be a boss. You don't have to be a supervisor. Anyone can lead from wherever their position is. And try to instill leadership and have them set the example. Don't look at your peer and wait on your peer to set your example of excellence. So when we look at identifying, we talk about discipline. And so we've defined that discipline to be the wherewithal and courage to consistently do the things right. When we look at being engineers, we're not looking for them to take a lot of risks. We want to do the proven things right, if that makes sense to you. We're innovative, but our clients aren't looking for us to take risks. They're looking for us to make it work and make it work properly, right, and every time. So discipline's important, and disciplined leaders are very productive, they're prepared, and they're proactive. Then the nature. We talk about the nature of the employee. And when we think about nature and of a leader, they're inspiring and they're compassionate to other folks. We talk about being generous. We want our folks to be generous and helpful to their neighbor, to their coworker, to the new engineer that comes in that needs a senior engineer to show them how this pump gets sized, how this line's going to be sized, how I'm going to calculate what the conduit field is for the electrical system. All of these things that are important, we are looking for leaders that by nature, they're honest, they're direct, they're trustworthy, and they're helpful. I'm a part of a group, an advisory group of business leaders, and one of the folks said something that really hit home for me. He says, we have something we talk about in our business about love the one you're with. How many of us now, when we are with someone talks right past you, or they're halfway listening to you while they're looking at their cell phone? And he said, so they started something at their business, and they said, love the one you're with. So when you're with that person, engage 100% with that person. And so that's one of the things we're trying to teach leadership in our business is when you're with that client, you're with that other engineer, you're with that accounting person, whoever it is, give them 100% of your attention. The last one is ability. Leaders want to be the best in their field. They want to be the most knowledgeable in their field. That's not about being the top of their field. They want to be knowledgeable in their field and strive for excellence, but they also understand when they need to reach out to the expert, the one more experienced. It's okay not to know everything. And so the ability to know and maximize their own capabilities, and great leaders ask questions, and great leaders help and seek answers. So those are three things that are important to us when we look for leaders in our company. And some final thoughts would be, I was thinking about, my mom was a third grade school teacher. My daughter-in-law teaches kindergarten in Newport News at one of the Head Start programs there for very, very, very tough. And I'm sure some of your roles that you're in, you see very tough, difficult situations. And I see the value that my mother brought to so many students. So I want to tell you guys here, what you do is remarkably important, and it's lasting. I think back today to 2 or 3 of my school teachers that not a year goes by, I don't think about them and what they taught me, and I think about, I can do this well because what they did when they were teaching me and teaching me well. So the other thing is creating great students to love with a love and a passion for learning. And because when you see the progression of what it takes to become a professional engineer, is they're just at the beginning of their learning when they finish all of their schooling. And so if they have a passion for that learning, then they're going to be extraordinarily valuable to their employer. Because just as I showed you the tools and how those tools have changed in design, if our employees were not willing to learn the new tools and not learn the new technology, then they would not be valuable to us 10 years from now or 5 years from now because they would be behind. The other I would say is inspire excellence, and please tell your students that grades matter. Some would say, well, you know, maybe 3 years or 5 years after your first or second job, maybe it doesn't matter anymore. But grades open up opportunities. When I came out of school in the mid-'80s, it was a great job market. And if you had a 3.5 or better GPA in engineering, which is a high GPA in engineering, you would have 6 to 7 job offers. If you had less than a 3, you cut your number of interviews to about a 10th. There was about 1 in 10 companies that would interview you, and you might get 1 job offer. So grades do matter. Now that I've put all that pressure on those students and grades, it's a competitive world. Love your students and love them well. They need it.